Today we're going to talk about how proportions are used within problems. We'll start out with problems like this that are similar figures. Similar figures have the same shape but are not necessarily the same size. Similar figures have corresponding sides and corresponding angles. So corresponding sides are just sides that match up to each other, and corresponding angles are angles that match up to each other. I'll go ahead and start to talk about that right now. If I had a triangle named ABC and a triangle named DEF, this says that they are similar, this squiggly line between it. The order of these letters matters tremendously. Because AB is first, it means that DE is its corresponding side. So AB will correspond to DE. Because BC is the second and third letter and EF are the second and third letter, BC is going to correspond to EF. Lastly, because AC is the first and third letter and DE or DF is the first and third letter, AC corresponds to DF. Now we can also talk about the corresponding angles. Angle A corresponds to angle D for the same reason. A is in position 1 and D is in position 1. Angle B corresponds to angle E, and angle C corresponds to angle F. So as we see our examples, we want to make sure that we notice the statement that's given. So sides are going to be proportional to each other. That's the reason we will be writing proportions to solve their missing side. And angles, they have to have the same measurement, so the angles are congruent. So my first example here, I'm going to pay attention to the top and how things are similar. I notice I have EF. Well, I'll go ahead and circle that in blue. And I want to find its corresponding side. EF is second and third position, so it matches up with JK. JK happens to be 15. What I'm going to do is I'm going to go ahead and start a proportion. I've got X matching up with 15. The next part that I was given was the 6. So I need to figure out where 6 matches up. Well, obviously, it's probably the 20 because that's what's given, but let's check. We've got DE is the first and second letter, and so is HJ. HJ is 20. So I will go ahead and put the 6 here and the 20 there. The X and the 6 were in the same triangle, and the 15 and the 20 were in the same triangle, but notice how the corresponding sides line up to each other. What we're going to do now is finish this proportion by cross multiplying. I get 20x equals 90. Divide by 20 on both sides, and I'll get that x is equal to 4.5 or 4.5. This type of example, though, has the triangles embedded in each other, so I'm going to need to redraw a picture. The first picture I have, I'll just make it smaller, TVU or TUV, and the second triangle is smaller, it's QUP. I'm going to go ahead and label the sides. This has 4 right here, and this has X from my picture. TV is right here at side 6, and VU I'm going to have to get by adding those two together, so I'm going to get 8. What I'm going to do now is I'm going to match side 6 up to its corresponding side. So TV is the first and third letter, and so is QP. So that means that it matches up to X. So I'll go ahead and write that, or start that proportion where I'll put 6 over something equals X over something else. I'm now going to match up my 8. My 8 is VU. VU is the second and third letter, and so is UP. UP is right here. 6 and 8 are in the same triangle, so I'm going to put 6 over 8. But 8 matches up, and its corresponding side is 4. Cross multiply here, I get 8x equals 24. Divide by 8, and I get x is 3.